Hi dears, this is Raji. In this video, we are going to start with a new chapter, that is electrolysis. It's a very simple chapter. If you try to understand certain concepts from the very beginning, it's going to be so easy for you and you can answer all the questions related to this chapter. Okay, so this is an introductory part of the chapter electrolysis, and we are going to discuss what is an electrolyte, what are the different types of electrolyte, and we will define what is electrolysis, and we will be discussing some board questions also related to that. So let's start electrolysis. Now see this picture. We know that metals are good conductors of electricity. We have learned about it. Okay, why a metal is a good conductor of electricity? Reason is that it will be containing some free electrons. Correct? Yeah. Or we can say that free electrons are responsible for carrying electric current through a metallic wire. Now the question is that, is it possible for a solution also to conduct electricity? Yes, it is possible. Look at this picture. We have taken little bit of sodium chloride solution and we are passing electricity through that. See, this bulb is glowing. Correct. So just like certain solids, solutions also can conduct electricity. If a solution is capable of conducting electric current, we call that particular solution as an electrolyte. Okay. So how can you define an electrolyte? An ionic compound in the molten state or in the dissolved state that allows electric current to pass through it is called as an electrolyte. Got it? We got a definition for electrolyte. So can you give some examples for certain solution that can conduct electricity? Here it is. Okay, certain acids can conduct electricity, certain bases and some salts also can conduct electricity. You can just remember some examples for electrolytes. Okay, we have defined that an ionic compound in the molten or in the dissolved state is conducting electric current. Why is it so? Why a solid ionic compound is not capable of conducting electric current? See this picture. Yeah, see, I have taken little bit of solid sodium chloride in this, and initially you can see that the bulb is not glowing. After some time, what we are doing, we are heating the sodium chloride to a very high temperature, around 800 degrees Celsius. The sodium chloride solid will be melting. Whenever it is getting converted into the molten state, see the bulb is glowing. Okay, if we are removing the flame, again sodium chloride will be solidified. That time, yeah, see the bulb is not glowing. So what does it indicate? It shows that, yeah, sodium chloride will conduct electricity only in the molten state or in the aqueous state. Got it? Yes. So they will be asking a question, why solid sodium chloride is not conducting electricity, whereas in the aqueous state also and in the molten state also it is a good conductor of electricity. How can you explain? You can tell that in the solid state particles are held together by strong electrostatic force of attraction. So when we are heating sodium chloride to a very high temperature, okay, that temperature is sufficient enough to break this force of attraction. As a result, what will happen? Sodium ion as well as chloride ion will be free to move. Correct, no? Yeah. At the same time, whenever we are dissolving little bit of sodium chloride in water also, we can see that, okay, it will be conducting electricity. So that time what will happen? Water molecule will be, yeah, dissociating the sodium and chloride ion apart. Correct, no? In between, water will come and stand. As a result, what will happen? This time also, the force of attraction between sodium and chloride will be considerably reduced. Got it? So, what is the criteria for a solution to conduct electricity? It should have free mobile ions in that. Got it? Yeah. So, remember, in a metallic conductor, what is responsible for carrying electricity? That is nothing but free electrons. What is responsible for carrying electric current in a solution? Positive and negative ions should be there. At the same time, it should be freely moving also. Got it? So we were telling that sodium chloride in the molten state also, in the aqueous state also is capable of conducting electricity. What is the reason? Because it will be having free mobile ions in that. Okay. Now the question is that, is it possible for all the solutions to conduct electricity? In order to test that, we are taking sodium chloride solution and we have taken some sugar solution also. The sodium chloride solution, now only we have seen, okay, it is capable of conducting electric current. Whereas if you are passing electricity through sugar solution, the bulb will not glow. So what does it indicate? It shows that sugar solution will not conduct electricity through that. What is the reason? Look at the picture. Okay, if you are adding little bit of sugar into water and stirring, it is not ionizing into positive and negative ions. There is no positive and negative ions. Instead of that, it will be existing as molecules only. So certain substances which won't allow electric current to pass through that, we call them as non-electrolyte. Okay. So they will be giving you a list. From that you will have to choose whether it is an electrolyte or non-electrolyte. Okay. See this one: distilled water, alcohol, kerosene, carbon disulfide, cane sugar, glucose, urea. All these substances are non-electrolyte. So you should remember that. So we came to know that certain solutions will be allowing electric current to pass through that readily. Why it is capable of conducting electricity readily? Because in the solution it will be containing positive and negative ion. For example, sodium chloride, it will be completely dissociating into sodium ion and chloride ion. Greater the number of positive and negative ion present in the solution, that will be a strong electrolyte, we will say. See, look at this one. The bulb is glowing so brightly, right? And in the solution, full of ions will be there. In the same way, if you are taking some sugar solution and if you are trying to pass electric current through that, we said that it won't conduct electricity. Why it is not conducting electricity? Because sugar solution will not ionize in water, you can say. It will be existing as molecules. Got it? At the same time, if you are taking some acetic acid solution and trying to pass electricity through that, see this one, the bulb is glowing dimly. Right? So why is it so? Reason is that acetic acid will be ionizing in solution partially, we will say. So as a result, very less ions will be present in the solution and mostly it will be existing as molecules only. Got it, no? Okay, that is the reason the bulb is glowing dimly. So they will be asking a question. If it is a strong electrolyte, what will be the species present in that? It will be full of ions, positive and negative ions. If it is a weak electrolyte, what will be the species present in that solution? Most of them will be existing as molecules and very less ions will be there. And at the same time, what is the species present in a non-electrolyte? Mostly it will be molecules only. So you should memorize that point, they will ask you. And at the same time, you will have to remember some examples of a strong electrolyte and weak electrolyte also. So how to memorize? If it is a strong electrolyte, it will be strong acid and strong bases. Correct, no? Easy to memorize, no? Sodium hydroxide and potassium hydroxide, all mineral acid like HCl, HNO3, H2SO4, all these are strong electrolyte. Along with that, sodium chloride, lead bromide, copper chloride, copper sulfate, certain salts are also strong electrolytes. Whereas all weak acid, all organic acids are weak electrolytes. And certain bases, weak bases like calcium hydroxide, ammonium hydroxide also will be weak electrolytes. See here, salts also, sodium carbonate, bicarbonate also will be weak electrolytes. You can just memorize the examples. Okay. See, we have discussed a very small topic related to the introductory part of chapter electrolysis, but you are now able to answer a lot of questions related to that. Read and find out. 3 different electrolytic cells A, B, C are connected in separate circuits. Electrolytic cell A contains sodium chloride solution. When the circuit is complete, the bulb in the circuit glows brightly. Electrolytic cell B contains acetic acid. In this case, the bulb glows dimly. The electrolytic cell C contains sugar solution and the bulb does not glow at all. Give a reason for all this observation. This is the question. So you can tell that in the case of sodium chloride, what we will write? It contains only ions. In the case of acetic acid, it will be containing ions and molecules. Less amount of ions and more amount of molecules. That is the reason the bulb is glowing dimly. In the case of sugar solution, it will be containing only molecules. What is the reason? Sugar molecules will not ionize in water. Okay, easily we answered it. Choose A, B, C or D to match the descriptions 1 to 5 below. Some alphabets may be repeated, they are telling. Okay, so they have given some A, B, C, D options and we are going to choose out of it which is the correct option. Molten ionic compound. Molten ionic compound like sodium chloride. Sodium chloride will be containing full of positively charged and negatively charged particles. So it will become a strong electrolyte. Correct? No? B. Yeah, carbon tetrachloride. I didn't discuss about that. Remember, carbon tetrachloride is a non-polar covalent compound. If you are adding that to water also, it won't ionize. You should remember. Okay, A. And aluminium wire. Aluminium wire will be, see the option is D, metallic conductor. Now, a solution containing solvent molecule, solute molecule and ions formed by the dissociation of solute molecule. So they are telling that in that particular mixture molecules are also there and at the same time ions are also there. So what type of a solution that will be? It will be a weak electrolyte. Option is C. Okay, that is the answer. Now a sugar solution with sugar molecules and water molecule. What is the answer? It will be A. It will be a non-electrolyte. Got it? Now see this one. Identify the weak electrolyte from the following. So they have given so many options. Sodium chloride, it is a strong electrolyte. What is the reason? It will be completely dissociating into positive and negative ion. Then what about hydrochloric acid? It's a strong acid. Strong acid will be a strong electrolyte also. Dilute sulfuric acid, that is also a strong acid. So that will be a strong electrolyte. And aqueous acetic acid is weak. What is the reason? It's an organic acid. It will be ionizing partially. So that will be the answer. Explain why solid sodium chloride does not allow electricity to pass through that. We have discussed that also. Okay, what's the reason? In the solid state, sodium ion and chloride ion will be held together more strongly by electrostatic force of attraction. So due to the absence of free mobile ions, sodium chloride in the solid state will not be able to conduct electricity. So it's so easy. We have discussed so many questions related to a very small portion of electrolysis. Keep on working hard. See you in the next video. Thanks for watching.